the title in the program is not very descriptive. Laser line analysis. I will start talking a little bit about what motivated the piece of the development of this whole software, visual weld inspection, hence the name FBead from weld beads. I'll talk a little bit about basics of contour analysis, in a nutshell, what's happening inside the code, a little bit about the Rev 5 implementation, a little bit about Rev 5 applications like the FMC adaptive welding job and the Austin Rover Gaging job. Just a brief mention of what we're doing in Rev 6 sim tracking, how we can take this software, Rev 6 software, and use it for gauging, and if I have time, general contour analysis. The problem we're trying to solve with this was gauging of weld beads and weld joints. And in addition to conventional sim tracking, where we're just trying to find, say, the root or a point where to direct the torch, I wanted to be able to measure dimensions like just like the ones that you see here. It's just like another gauging problem, only that what you're trying to gauge is a little more complicated than just holes. The general, I guess I'll try here to have some block diagram, you can call it, of what's happening or where LLA fits in the overall vision processing. We start with frame grabbing, potentially some image processing, then stripe extraction here, and we have experimented with adaptive thresholding, instead of just plain thresholding that's happening in F-edge, and spatial filtering, where you pick up the stripe on the basis of its size and continuity rather than on its brightness. I won't go into any detail in that, but I will concentrate on what LLA does, which is contour analysis and recognition.
And I'm going to try as hard as I can to get the schedule back on track. So you can all take the rest of the afternoon off. Now we're back on schedule. Okay, the discussion that we have to have about communications is that we are making a drastic move in processing gauging systems where we now are coming to the limitation of processor horsepower, is limiting the number of items that we are measuring in our gauging system. It seems that everybody wants everything measured and they all want it for $30,000. So what we've done to try to compensate for that is we have split into multi-CPU configurations where we are now doing loosely coupled multiprocessing or tightly coupled networking. You could look at it either way. And the easiest way to draw this, and I used my view graph from before, is that we have the master CPU and N slave CPUs, where N is limited only to the number of communications ports on the 4932 and the available bandwidth that the system can receive.
About how flexible or simple we should make this. Most of the debate centered on what functionality to include. The final product, which was agreed upon by most people, was to have a relatively simple menu interface. It's primarily a picking system. You can have at most 9 entries on the screen. It only has really 2 ways of returning information. It returns the pick number of the menu item, and or it evals an optional string, which is part of the menu item. It is to be the official standard interface for all applications here. We're hoping that about 90% of the applications can use it. And one thing that we have added since the spring revision is we've been forced to incorporate some of the password protection. It was originally envisioned that the password protection would sit on top of the menu. It was found out to be very cumbersome and very slow. So there's now what's basically a bit mask that's stuffed in underneath. And what will that allow you to do is, depending upon your current operating privilege, certain of the menu picks will be allowed or disallowed. And if they're disallowed, they will not even appear on the menu. There will be no holes, but the rest of the menu items will shrink up, and the auto numbering scheme will take care of that.